In this example, we start with the polynomial p above, and we're told that x minus 2 is 0 of this polynomial, and we would like to find the others if they exist. So for each factor, we have a 0 and vice versa. So if we can identify all of the factors, then we can find all of the zeros. So we know that x equals minus 2 is one of the zeros. So this means we know one of the factors, namely that x minus 2, x plus 2, in other words, is a factor. Okay, and so therefore we can divide this factor, x plus 2, into the polynomial p, which is x cubed plus 9x squared plus 6x minus 16. And so we do this polynomial long division like the other examples. I need to multiply this divisor by x squared so that the leading term will match the leading term of the polynomial. So we're going to first multiply the divisor by x squared, and doing that work on the side, taking x squared times x plus 2 gives me x cubed plus 2x squared. And now we're going to subtract this, and that's the same as if we were to take minus x cubed minus 2x squared and we add this. And so here we get the cancellation of the leading terms, and combining the x squared terms gives us 7x squared, and bringing down the remaining terms we get 7x squared plus 6x minus 16. And now we need to identify, well, what should I multiply? X plus 2 in order to cancel the leading term 7x squared, and that would be 7x. So we're going to put 7x, and we're going to multiply 7x times x plus 2 times the divisor, and that gives us 7x squared plus 14x. And now we're going to subtract that. So in other words, I'm going to add minus 7x squared minus 14x. So when we add this, we get leading terms canceling, and what's left is minus 8x minus 16. And now we finally say, in order to get the leading term, minus 8x, I need to multiply the divisor by minus 8. And hopefully we wind up with a remainder of 0, since this had better be a factor. X plus 2 should be a factor. And we see that, yes, we get minus 8x minus 16. So when I subtract that, that's the same thing as adding 8x plus 16. And so adding these, everything cancels, and we have a remainder of 0. Great. So what this means is this polynomial, p of x, we can write as the factor x plus 2 times x squared plus 7x minus 8 plus our remainder of 0. So we've got it factored into the linear factor and this quadratic factor. And now we can try and factor it further. We know how to factor quadratics, or at least when it's possible. And so here I can factor this quadratic into x plus 8, for example, and x minus 1. Okay, and we can check that that gives us x squared plus 7x minus 8. So now we factored p of x into 3 different linear factors, and for each of these factors we get a 0. So now we see, well, we knew that x equals minus 2 was a 0. We now see from the factor x plus 8 that x minus 8 is a 0, and from the last factor, x equals 1, are the zeros. Each of these zeros has multiplicity 1. So we have 3 different zeros.